Hey there, I'm Camden Rogers with Universal Lithium Battery Supply, and we build lithium batteries for forklifts. But lithium batteries didn't start with us. Lithium technology has gone through decades of trial, error, and breakthrough to reach where it is today. And now it powers everything from the phones in our pockets to the forklifts running in today's warehouses. So let's take a quick look at how lithium got here and how companies like ours are helping shape where it goes next. The element lithium was first discovered in 1817 by a Swedish chemist. It's a light, silvery metal that reacts quickly with air and water, and from the start it stood out as something unique. For more than a century, lithium didn't have much practical use though. It slowly found its way into a few niche areas like heat-resistant glass, grease, and later even medicine, but would not find its place in batteries until many decades later. By the late 1960s and 70s, the world was becoming more and more mobile. Radios, cameras, and early computers were everywhere, and engineers were desperate for lighter, longer-lasting power sources. The batteries at the time worked, but they came with plenty of frustrations. They were heavy, short-lived, high maintenance, and everyone wanted something smaller, cleaner, and longer-lasting. The challenge sparked a wave of experimentation, and in 1973, an Exxon researcher created the first working lithium battery. Instead of the lithium-ion design that we use today, his version used metallic lithium, which stored an incredible amount of energy, but also made it unstable and risky. The batteries overheated easily and weren't safe for practical use. So the research continued. A few years later, companies in Japan, most notably Panasonic and Toshiba, revised the idea using safer materials and released the first commercial lithium batteries in the late 1970s. These were small, single-use cells that powered cameras, watches, and early medical devices. They were light, powerful, and reliable, the first glimpse of lithium's future. For the first time, lithium-powered products reached everyday consumers, showing what this new battery could really do. Early lithium batteries were impressive for their power, but they had one big limitation. They couldn't be recharged. Once they ran out, they were done. Engineers wanted something that could deliver the same strong performance while recharging again and again, just like lead-acid batteries already powering vehicles and equipment. So the search continued. Sony was the next to take up the challenge, and in 1991, their engineers made history with the world's first rechargeable lithium battery. They found a safer way to store and release lithium's energy, keeping its power while eliminating the instability that held earlier versions back. It was lighter, longer lasting, and could be recharged hundreds of times. The impact was immediate. Sony used it first in their handheld camcorders, but soon it was the same technology was powering laptops, phones, cameras, and eventually the electronic vehicles and industrial machines we rely on today. That same innovation didn't just improve batteries, it helped launch the modern tech era, proving that lithium power could truly change how the world runs. As lithium batteries spread across the world, researchers kept pushing for something even better. The earlier designs were powerful but used materials that could overheat or fail under stress, a concern as batteries got larger and began powering more demanding devices. In 1996, a team at the University of Texas developed a new lithium chemistry that would change everything again, lithium iron phosphate, or LFP. Their goal was simple: make the current lithium batteries safer, more stable, and longer lasting. LFP traded just a little bit of energy density for an incredible durability and safety. It was tougher, more predictable, and could withstand thousands of charge cycles without losing strength. It made it ideal for electrical vehicles, solar, storage, and industrial power, places where reliability matters most. Through the 2000s, LFP evolved fast. Manufacturers refined the process, improving its performance and cost until it became one of the most trusted chemistries on the market. And today, it's the backbone of many of the world's safest and most durable lithium batteries, including the ones built right here at ULBS. At ULBS, we're proud to be part of the next chapter in lithium's story. We manufacture lithium forklift battery packs built with CATL's LFP cells, the same trusted technology used by leading electric vehicle manufacturers worldwide. Our batteries are true drop-in replacements for lead-acid systems. No watering, no corrosion, no downtime, just reliable power that keeps operations moving. They're designed to make lithium easier with smarter charging, longer lifespan, and consistent performance shift after shift. But more than that, ULBS is focused on what lithium represents: progress. From the discovery of lithium to the development of LFP, every step has been about making power safer, stronger, and more efficient. And that same drive for improvement is what fuels us today. We're not just about building batteries, we're carrying forward over 2 centuries of innovation and putting it to work in the modern warehouse. Lithium has come a long way from a discovery in the 1800s to powering the forklifts and factories that keep our world moving today. In Universal Lithium Battery Supply, we're proud to carry that torch forward, building the next generation of reliable, efficient, and sustainable power.